Welcome to KSRCT 1994. I am Dr. N. Uttarasamy, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchangod, Namakkal District, Tamil Nadu. In this video, we are going to discuss Bayes' theorem and its proof and problems of the course Probability and Statistics. Introduction to Bayes' theorem. The concept of conditional probability is introduced in elementary statistics. We noted that the conditional probability of an event is a probability obtained with the additional information that some other events has already occurred. We used the probability of B given A to denote the conditional probability of event B occurring given that event A has already occurred. This conditional probability of B given A is equal to probability of B intersection A divided by probability of A, and the probability of A is not equal to 0. This Bayes' theorem is also widely used in machine learning, where we need to predict classes precisely and accurately. An important concept of Bayes' theorem, named Bayesian method, is used to calculate conditional probability in machine learning application that includes classification tasks. For machine learning engineers, it serves to prepare more detailed prediction model. Bayesian inference gained application in various projects including medicine, sports, philosophy, science, engineering, law, etc. Applications of Bayes' theorem in artificial intelligence. It is used to calculate the next step of the robot when the already executed. Bayes' theorem is helpful in weather forecasting. It can solve the Monty Hall problem. Bayes' theorem statement: let A1, A2, A3 and so on, A and B and N mutually exclusive and excastive events. Mutually exclusive events. Two events, when we say two events are said to be mutually exclusive, the occurrence of one affects the occurrence of the other. So that is, we can take a coin. So we are tossing a coin. There are two possibilities here, head and tail. If we head, we cannot get tail, and vice versa. So this is mutually exclusive events. And excastive events. Total number of possible outcome in any trial is called it as excastive events. Suppose we can take a coin and we are tossing a coin. We are getting head. There are two possibly head and tail. Head one and another chance tail. So totally that is 2. And in other words, we can take a single tie. So we can get that is possibility, that is 1, 2, 3 and so on up to 6. So there are 6 possibility. So this is excastive event. So this probability of AI is not equal to 0 for I is equal to 1, 2, 3 and so on n. Let B be an event such that B in union I is equal to 1 to n AI. Probability of B is not equal to 0. Then probability of AI given B, that is equal to probability of AI into probability of B given AI divided by summation I is equal to 1 to n probability of B given AI into probability of AI. So now we are going to prove this Bayes' theorem. Proof of Bayes' theorem: given B in union I is equal to 1 to n AI. This can be written as B is equal to B intersection union I is equal to 1 to n AI. So this intersection B and union I is equal to 1 to n AI. So that is equal to B. By distributive law, we can write union I is equal to 1 to n B intersection AI. That is a distributive law. A into B plus C is equal to AB plus BC. So therefore, we can take probability on both sides. That is, probability of B is equal to probability of union I is equal to 1 to n B intersection AI. So this is, we can write summation I is equal to 1 to n probability of B intersection AI. probability of B intersection AI are mutually disjoint events. So therefore, probability of B is equal to summation I is equal to 1 to n probability of AI into probability of B by AI. That is compound probability theorem. So also we have probability of B intersection AI, that is equal to probability of AI by B into probability of B. So we can write this probability of AI by B, we can take this opposite side, probability of B intersection AI divided by probability of B. So this is, therefore probability of AI by B is equal to, so probability of B intersection AI, that is equal to probability of AI into probability of B by AI divided by summation I is equal to 1 to n probability of AI into probability of B by AI. Suppose I is equal to 1 and 2 means we can write probability of A1 into probability of B by A1 plus probability of A2 into probability of B by A2. So for for an example, there are 2 machines or 3 machines. So I is equal to 1, 2, 3 for 3 machines. So this is the proof of the Bayes theorem. Next, we can see a problem. 3 factories produced light bulbs to supply the market. Factory A1 produces 20% of the items and factory A2 50% of the items and factory A 30% of the items produced. 2% of the bulbs produced in factory A1 be the defective bulbs and 1% of the bulbs produced in factory A2 and 3% of the bulbs produced in factory A3 are defective. So therefore the defective bulbs 2%, 1% and 3% for the factory A1, A2, A3 respectively. A bulb is selected at random in the market and found to be defective. So what is the probability that this bulb was produced by factory A1? So in this question we are going to calculate only factory A2. So in some of the problem we want to calculate factory A1, A2 and A3. So we can compare and find we can easily give the conclusion. So in this problem we are going to find out the probability that the bulb was produced by factory A2 only. Solution, let the probability of A1 that is equal to 20% of the items produced and the probability of A2 is equal to 50% and the probability of A3 is equal to 30%. Then the probability that the bulb selected at random is formed from factory A1, A2 and A3 respectively. Probability of B be the probability that a defective bulb is selected. So probability of defective bulb from factory A1, that is probability of B given A1, that is equal to 2%, and probability of B given A2 that is equal to 1%, and probability of B by A3 that is equal to 3%. So this is defective bulbs from factory A3. Represent the conditional probability that a bulb is defective given that it is selected from factory A1, A2 and A3 respectively. Now we calculate that the conditional probability that the bulb was produced by factory A2 given that it is defective, written as probability of A2 given B. So using Bayes theorem. So using Bayes theorem for the second factory, probability of A2 given B. So this is probability of defective bulbs from factory A2, that is equal to probability of A2 into probability of B given A2 divided by summation I is equal to 1 to n probability of AI into probability of B by AI. So here there are 3 factories, factory 1, 2 and 3. So I is equal to 1, 2, 3. So in this denominator I is equal to 1 probability of A1 into probability of B by A1 plus probability of A2 into probability of B by A2 plus probability of A3 into probability of B by A3. Sum of this value, this is denomination. So now, from the given problem we are substituting all values, that is equal to 0.2777. So this is the probability 0.2777. although factory B produces 50% of the bulbs. The probability that the selected, that is defective bulb, comes from this factory is low because the bulbs produced by this factory have low probability of being defective. Similarly, we can solve a problem. Approximately 1% of the women aged 40 to 50 have breast cancer. A woman with breast cancer has a 90% chance of a positive test from a mammogram, while a woman without has a 10% chance of a false positive result. What is the probability of a woman has breast cancer given that she just had a positive test? So in this problem, that is approximately 1% of the women have breast cancer, and at the opposite side 99% of the women have not breast cancer, and a woman with breast cancer has 90% chance positive test from a mammogram. So in the another side it is 10%, that is opposite side. Okay, now first we can see the diagram. That is cancer, that is equal to what? This is 10%, that is 0.01, and no cancer 99%, that is equal to 0.99. So in the cancer there are two possibility, that is one is positive result and another 10%, that is what? Negative result. So in this problem, that is a 90%, that is 0.90, that is positive result, and opposite side 0.10, that is a negative results in the cancer, and another side no cancer, that is 0.99 possibility, 0.99, and here that is positive test, positive result 0.10, and negative result 0.90. So now we are going to use Bayes theorem. Probability of A given B, that is equal to probability of B given A into probability of A divided by probability of B. Probability of B is not equal to 0. So B be the woman has breast cancer and A be a positive test. So based on this Bayes theorem, we can write probability of cancer given positive, that is equal to probability of positive result given cancer into probability of cancer divided by probability of positive result. Just we can refer this from the problem, we can take all values, and here we are getting 0.083 possibility probability. In terms of percentage, that is 8.3%. So therefore the probability of a woman has breast cancer, a positive test is 8.3%. Similarly, we can apply all real world problem, we can easily find out the probability. Thanks for watching. Keep learning and growing. Thank you.